Excited Utterance, the Evidence and Proof Podcast, Episode number 14, Jay Koehler, Testing for Accuracy in the Forensic Sciences. Welcome to Excited Utterance. I'm your host, Ed Cheng from Vanderbilt Law School. Excited Utterance is your podcast for cutting-edge scholarship and developments in the world of evidence. Our goal is to bring a virtual workshop to you every week throughout the academic year. This week, our guest is Jay Koehler. Jay is the Beatrice Kuhn Professor of Law at Northwestern University School of Law. Jay teaches evidence and courses on forensic science and statistics. His scholarship often focuses on quantitative reasoning in the courtroom, either from a behavioral psychology or a statistical perspective. His latest article, entitled Forensics or Forensics, Testing for Accuracy in the Forensic Sciences, takes the forensic community to task for failing to measure the error rates associated with the various forensic techniques. In the paper, he examines some of the institutional forces that have led to the current sad state of affairs, as well as proposes a new type of proficiency testing program, aimed not just at improving or assessing specific analysts, but more broadly, ascertaining the accuracy of a technique more generally. All right, so Jay, welcome to Excited Utterance.
It's great to be here.
Your article takes the forensic community to task for not measuring error rates and basically implying perfect accuracy. How did we get into this mess in the first place? If you think about it, in any other walk of life, if you claim perfect accuracy, it would be almost ridiculous. Why did the forensic community decide to choose this path?
There's plenty of blame to go around. I think the forensic community is partly to blame, and I think the scientific community is partly to blame. I think the legal community is partly to blame. So you started with the forensic community. Let me go to them. We have to look at the history, first of all. And the history of forensic science is such that forensic scientists have learned for more than 100 years that they're able to do something in particular that most scientists think they're not able to do, and that is to identify with perfect accuracy the source of any given print or marking or forensic sample. So the idea is that if only you knew what I knew, you too would be able to determine the source of this print or marking, and once you've determined the source, you can state it with 100% accuracy, 100% confidence. There's really no risk of error. It's just a matter of properly applying the techniques that we know work because we've been taught that they work with 100% accuracy.
And you presaged my next question, which is, in one part, it is the forensic community's fault, but then there's a question of how did we allow the forensic community to get away with this? So who is it that has been asleep at the switch?
Again, I would say there's a couple other groups that are at fault. It's the scientific community and the legal community. I'll start with the scientific community, if you don't mind, because the scientific community had a lot of chances in the last 20 or 30 years to fix this, especially with the advent of DNA evidence. They had a lot of chances and they blew it. First, I should say that the National Academy of Sciences in particular had their opportunities, and I think they blew it. There was a report on DNA evidence back in the early 1990s, and it goes by the name NRC-1. It stands for National Research Council 1, where they basically took a look at DNA evidence, which was new in the early 90s, and they said, it's good, it's okay, it's ready for prime time. And that's what the scientific world was expecting, and it was a huge, huge report. But it also said no laboratory should admit or have their DNA evidence admitted into court without first going through proper proficiency tests, blind proficiency test, blind external proficiency test, which we can talk about later, in order to identify their error rate. So this committee knew that error rate was an important thing to measure, that it should be measured in the context of DNA at least, and that could have then carried over to other forensic sciences, and it didn't. One reason it didn't is where I think this committee blew it. They weren't specific enough about why it's important to identify error rates. And by that I mean, they didn't say that without a measure of error rates, we simply don't know, or jurors can't determine the probative value of this evidence. So the error rate really identifies the probative value of the evidence. And we've had it wrong for many, many years where we think it's the random match probability. It's those 1 in a million, 1 in a billion random match statistics that are associated with DNA evidence that we think identify the probative value. But as you know, I've been saying for decades that it's actually not that at all. The random match probability just means it's very unlikely that it's a coincidental match, a low match probability, but it's the error rate that ultimately controls the probative value of the evidence. NRC 1 didn't make that clear.
Now, why did NRC 1 and 2 basically focus on random match probability? And as I understand it, NRC 2 is the one that really focused in on the random match probability. Why was the move toward random match probability as opposed to the error rate in the sense of proficiency testing and that kind of thing?
We could measure it. We had good data sets, and if you can measure it, that's where the focus was going to be. And error rates were and always will be extremely difficult to measure. There's some good science associated with those profile frequencies. We got better and better data sets, and so naturally the focus, I think, fell on those data sets, and many scientists really were most interested in that. That's what interests a lot of professional geneticists. What are the profile frequencies? NRC2, which you mentioned, they came along a few years later in 1996. They mucked things up even more because they actually directly contradicted what NRC1 said about the importance of error rates. They actually said error rates are actually not important because after all, you never know. Any given case is unique, and an error rate is just a general finding about the risk that other labs at other times in other places, perhaps using other techniques, have made a mistake. And so why should we use that in this individual case? What we should be doing is focusing on this case and this test. And if there's reason to believe this analyst made an error, well, then let's talk about it. But let's not bring in vague, general, hypothetical, they've been called hypothetical error rates. It only mucks things up because they're not applicable to the target case. And unfortunately, that pretty much wiped out proficiency testing in the world of DNA since that time. For the last 20 years, we haven't had any, or at least very, very few, blind external proficiency tests. As a result, we have no idea what the error rates are in DNA. And a lot of people think we do know them because they say it's 1 in a million, it's 1 in a billion, and those aren't error rates. Those are random match probabilities.
Why is it that we want to care about error rates as opposed to the random match probability?
I would say we want to care about error rates because if the risk of, let's say, sample recording error, that's one type of error. If the risk that the analyst is going to make a recording error and falsely incriminate someone is, let's say, 1 in 1,000, that means there's a risk of 1 in 1,000 every single time an analyst conducts an analysis that he's going to falsely incriminate an innocent person if they make these recording errors 1 time in 1,000, at least in a false positive sort of way. If the random match probability is much smaller than that, like 1 in a million or 1 in a billion, what that means is the risk of a coincidental match is extremely unlikely. And if we have an error, it's almost certainly going to be a recording error or something other than a coincidental match error. So it's like focusing on the least significant risk of error. When we focus on the risk of coincidental match or the random match probability, we're focusing on exactly the wrong thing, the thing that is least likely to occur. What we need to focus on are what are the things that are most likely to occur. And lab errors, and I just put them all together, whether it's recording error or mix-up or contaminations, that sort of thing that I just call lab error is much, much more likely than 1 in a billion or 1 in a million. And that sets the threshold for the probative value of the evidence. The random match probability is essentially irrelevant.
And how would you resolve the problem that was identified in NRC 2? That what you're going to get are these error rates, and we'll talk a little bit more later about how you measure them, perhaps. The later part of your article talks about that. How would you deal with the fact that the error rates that we have are very general and not specific to the particular lab or the particular examiner? This is effectively some kind of reference class problem that you have to get around in order to make the information useful.
You are obviously the expert on reference class problems, and it's a problem. I don't want to say that the error rates that could be identified with proficiency tests necessarily apply with great specificity to any individual case. What they do is they give the judges, they give the juries a ballpark figure for what we're talking about. If we find out that the risk of laboratory error is, let's say, 1 in 100 or 1 in 50, then a judge can say, well, I don't know if the risk is 1 in 50 in this case, but that gives me a starting point. And now I can move that 1 in 50 subjectively in my mind. I can move it around a little bit based on some other factors in the case, maybe the experience of the analyst or maybe the care with which the analyst appears to have conducted this task. But if there isn't any other evidence, then you want the judge and you want the juror to focus on that 1 in 50 as a starting point, as a base rate, as opposed to the 1 in a million or 1 in a billion.
Let me poke you a little bit more on this judge and jury question. Where do you want to see this error rate evidence being used? Is this really a Daubert question where the judges should police this error rate factor more stringently? Or is it that what you really would like to see is not necessarily Daubert challenges based on error rate, but discovery, in fact, that defendants will have access to these error rates and can present them to the jury. And then, as you said in the answer to my last question, the jury will be able to put things in context.
I would say both, but my personal focus, my belief is that it's more important at the juror level than at the judge level. And I say that because I think much of this evidence is going to pass admissibility. But I still want judges to have it because there are still some forensic sciences that may not pass, where the error rate might be judged by a trial judge to be too high for a jury to even hear. It's a bit of a subjective call by a judge, and I want the judge, though, to at least have that error rate data. In the case of DNA, whatever those error rates are, it's almost certainly going to pass some threshold, whether the error rate's 1 in 1,000 or 1 in 500 or even 1 in 50. False positive error rate, if we have numbers like that, it still seems to me the evidence is probative. It still should get by a Daubert hearing. As far as the jury goes, though, now it's very different. If the error rate that is admitted is, the false positive error rate is 1 in 50, the jury may not give great weight to that DNA evidence, particularly in the context of having some exculpatory evidence from the defendant. And so that could actually change the outcomes of trials. As opposed to what some forensic scientists have argued for, they've said, and just to jump ahead here, some forensic scientists have said, well, this is all sort of pointless because what's a jury going to do with those error rates anyway? And I don't know if that was one of your next questions.
That's right.
Everybody comes to that question eventually. Well, what are we really going to do with these numbers even if we had them? And this forensic scientist, Christophe Champeau, you may know as well, has argued in print that it's really kind of pointless because if we gave jurors a number, like 1 in 100 or 1 in 1,000, they're simply going to ignore it because they're going to say, well, I don't have any specific reason to doubt this particular analysis, and so I'm just going to fully credit the analysis. If people are doing that, then that's a mistake, and we're going to have to work on jurors. We have to figure out some better way to present the 1 in 50 or 1 in 1,000 or whatever the error rate is to jurors so they're not fully crediting it. He may be right. Maybe a lot of people are going to be inclined to disregard a relatively small error rate, but we need to make jurors aware that there's a difference between a 1 in 50 and a 1 in 1,000, especially in a close case.
That was, in fact, the question I was going to ask, which is, well, jurors are not going to really understand. We largely limp along on this idea that jurors have some vague idea of whether or not it's DNA, which is generally thought to be better, or it's some other kind of forensics, which is generally thought to be a little worse. Then you just allow them to qualitatively touch on these issues. In many ways, I was going to play devil's advocate because I like having the numbers. I would prefer that we show the jurors that. But your view, I take it, is similar to mine, which is that the quantitative information is still valuable and that we don't want to move to an entirely qualitative regime here.
No, I don't like the qualitative regime at all. I know that's a very popular thing to do, to talk about error is very unlikely and that sort of thing. All that's doing is introducing a lot of unnecessary subjectivity because very unlikely to you means something very different to me. I think we should introduce the numbers and then try to get people to understand what the numbers mean so that we narrow the range of difference that individuals may have when they think about a 1 in 100 or a 1 in 1,000. That's its own problem. I'm not saying that's an easy problem. That's a difficult problem to get people to appreciate the value of a fairly low error rate. These error rates are not going to be 1 in 2, which everybody easily understands. They are going to be more like 1 in 30, 1 in 150, or 1 in 6,000. But we need some training. We need some way to convey that, not just to the jurors, but to the attorneys, to the experts. The expert themselves needs some way to convey this error rate information and not say, well, Even though the error rate is 1 in 600, in my judgment, the risk of error is much lower than that here. We shouldn't allow that sort of thing.
Let me move a little bit to your discussion of fingerprints. So you note in your article that there has been some progress on error rates, that error rates have been calculated in the fingerprint area to some degree. Can you summarize briefly some of those results and why you think those are actually insufficient and not actually what we want?
As far as proficiency test studies that have been done go, the studies that I mentioned in this paper are very good. One is by Ullery et al. In, I believe, 2011, and the other, I think the name is Pacheco, I'm not sure how to pronounce it, Pacheco et al. In 2014. I might refer to that as the Miami-Dade study. Both of them were studies with actual fingerprint examiners. They were given pairs of prints, and they were asked to declare matches or non-matches, and some matched and some didn't match in truth. In general, the results were pretty good in the false positive error sense. I believe that in both cases, the false positive error rates were under 1% when you take into account extremely minor variations in the prints. And so that's good news. Generally, that's good news for the profession. Generally, when a fingerprint analyst declares a match, the risk of false positive error appears to be on the order of 1%, at least in studies like this. The reason I criticize those studies, the fault that I find is, number one, these are volunteers. They're not your run-of-the-mill fingerprint examiner. Number two, they know that they're in studies, which I think makes a big difference. And there's a lot of evidence that makes a difference, that analysts do respond differently when they know they're in a test versus when they know they're in an actual case situation. And specifically, when they're in tests, they're much more cautious. They're very nervous about committing a false positive error that can be traced to them. Number three, I question the amount of interest, for lack of a better word, that the researchers may have. I don't want to imply in any way the researchers are dishonest or cheating or doing anything, or even motivated to come up with a certain result. But in the name of science, when you have an interested party like the FBI running these tests, when you have researchers who actually are being paid by the FBI, work for the FBI, running tests that affect the FBI's credibility, and the FBI does do the lion's share of the fingerprints in this country, I think that's a bad idea. And I think what we need is some disinterested agency running these tests. So that's the primary fault that I find, that they're volunteers, they know they're being tested, and that they're not being run by disinterested parties.
So take that further. How do we fix this? What's your thought on how we get out of this mess and have greater levels of proficiency testing and more information about error rates?
I think we need a government agency to run the show, something like the National Academy of Sciences, some sort of subgroup where forensic scientists work with statisticians like yourself, with psychologists like myself, and a variety of other people in designing a very good set of proficiency tests. And we can talk about what those features might look like. But the idea is that those exams then get sent around to laboratories throughout the country. And by the way, it wouldn't be extremely burdensome, because I don't have in mind making every examiner participate in lots of tests all the time. In fact, my sense is most examiners won't participate in a proficiency test on a regular basis, because I think our goal should be to just identify what's the rate of error on average with firearms analysis, DNA, fingerprints, paint chips, whatever it might be. And so these tests get sent around to the different labs as if they were casework. That's the idea. And the analysts won't know that they're actually participating in a test. And because I'm not that interested, or I think we shouldn't be that interested in identifying an individual examiner's error rate, because I think that's impractical, I think what we want to know is industry-wide, because that's what gives the judges a ballpark figure for how good this stuff is. A separate question is, how good is this analyst? That's its own issue, but I think these tests can be run in a practical way.
And this is the distinction that you make in the article about type 1 and type 2. And here, I'm pretty certain that this has nothing to do with type 1 versus type 2 error. It's really about, are you conducting the test for internal validation purposes, which is where you're trying to figure out whether an examiner is any good, versus when you treat the system as a whole and you basically provide exemplars for casework to test the accuracy of the system as a whole.
Yeah, that's a great way to say it. You said it better than I did in the article. Well, I'm trying to distinguish between type 1 are the kinds of proficiency tests that we currently do, where we're trying to make the examiners better. And that seems to be the forensic science community's goal. We give these tests in order to figure out what the problems are and how we can make the examiner better. The problem is those tests aren't designed to identify rates of error. They're designed to figure out strengths and weaknesses and where more training is needed and where the individual analyst or individual laboratory needs more focus. The analogy I give there is we buy SAT practice guides to help us figure out, are we good at math? Do I need more work on vocabulary problems and that sort of thing? And so those are tests, but it doesn't make a lot of sense to talk about exactly how many problems you missed on the SAT practice test when you're really taking those tests to figure out what do I need to beef up on before the actual test. The actual SAT test is analogous to my type 2 tests, where the goal now is no longer to make you a better mathematician. The goal now is no longer to make the forensic scientist better at his job. The goal is to satisfy an external constituency's interest in knowing how good are they. And that's what a type 2 test is all about. That's what an actual SAT test is all about. And that's what we don't have today. Incredibly enough, we don't have any type 2 tests.
Let me ask you a final question. The problem that we've been talking about, this lack of error rate, as you suggested at the beginning of the interview, it's been around, broadly speaking, for quite some time. Are you optimistic about the chances for reform over, say, the next 10 years? And if so, why? And if not, why not?
I am not optimistic. Sorry to say, I'm not optimistic. I put that in writing as well. Because a lot of constituencies have to come together and agree. Number one, they have to agree that there's a problem. Right there, I think we run into trouble because a number of groups have said, a number of very influential people have said, there really isn't a problem here. If there is a problem, the answer is retesting. The answer is not to try to identify rates of error that have nothing to do with the instant case, sort of the NRC2 argument. So that's a big one. It's expensive. It will be expensive. My sense is the benefits are worth it, both in terms of what judges get and what jurors get. And I think it's worth it in terms of fixing the misconceptions that we have. There's going to be another side that says, no, that won't fix the misconceptions. Jurors aren't going to know what to do with that evidence anyway. The Champeau argument, essentially. Given the expense, given that people say there's a different way that we should be going, we shouldn't talk about hypothetical error rates, and given that some people say jurors won't make good use of this anyway, I'm not optimistic about this happening in the next 10 years.
Well, on that depressing note, Jay, thanks for being on the show. Your work on various types of statistical evidence has been a real resource for me over the years, and I'm delighted we were able to share some of it with our audience.
Thanks, Ed.
As we discussed in the interview, the lack of error rates for forensic techniques is a problem that has been with us for quite some time now. And if Jay's gloomy prediction is true, it will be one that will persist well into the future. In many ways, it is a problem that is both understandable and puzzling. Understandable because established practitioners in any field have little incentive to test themselves and potentially show themselves to be wrong or foolish. Puzzling because at some point in time, the legal system established a norm of using these techniques and their conclusions without demanding a measure of their accuracy. I should re-emphasize that despite playing devil's advocate at the time, I agree with Jay that we need quantitative measures of accuracy, coupled with research on how to best teach jurors how to use them. For many of these techniques, people have little inherent sense of their evidentiary worth. If an expert declares a match between a footprint and the defendant's shoe, few of us have any experience telling us how reliable such a match might be. Indeed, even in places where we think we know how to weigh evidence, for example, credibility determinations about whether a person is lying, the social science suggests that we are much worse than we think. The irony is that what Jay proposes, essentially a form of blind testing, and what many of us view to be the dream, is not some radical idea, at least outside the legal context. It is, after all, what we'd expect to find in any modern manufacturing process with quality control. And the fact that we test toasters in this way, but not the forensic techniques that decide guilt or innocence, is the greatest mystery of all. That does it for this week's episode of Excited Utterance. And with this, our 14th episode, we reach the end of the first season of Excited Utterance. I want to thank all of you for tuning in this fall semester and making this podcast a success. Excited Utterance will pick up again in the spring semester, starting January 9th. Until then, I want to wish you all a happy Thanksgiving and a wonderful holiday season. Support for Excited Utterance was generously provided by Vanderbilt Law School's Brandstetter Litigation and Dispute Resolution Program, as well as the Vanderbilt Institute for Digital Learning. The associate producer for this episode was Alex Nunn, and the production editor was Carson Smith. Music was provided by the Vanderbilt University Blair School of Music's Children's Cello Choir under the direction of Kirsten Castle-Greer. I'm your host, Ed Chang, and I hope you'll join me again in the new year on January 9th, when we'll take on another new work in the world of evidence and proof.